Today I'll be covering inverse functions. An inverse function undoes the original function. If we put in an input x and get an output y in an original function, putting the output into the inverse gives back the original input. Here's a mathematical definition if you want to pause. Some common inverse functions include e to the x and ln of x and sine x and arcsin of x. The formula for the derivative can go as follows. You start with f of g of x is equal to x, where f and g are inverses. Then you differentiate both sides and use chain rule. After that, isolating for g prime of x, which x is equal to f of x, gives you this formula. F prime of x cannot equal 0, and f must be differentiable at x. Here's a simple example with an inverse function. Let's say we want to find the derivative of an inverse at x equals 2, and this is our original function. Well, recalling this formula, the first thing we need to do is solve for when f of x is equal to 2, as that's the input into our inverse. Then we get the derivative of our original function and plug in our x value that we solve for into that. After that, it's just plug and chug into the formula. Next up are trig functions or inverse trig functions. Let's say we want to find the derivative of arcsin of x. Well, first we isolate for x and differentiate both sides, making sure to use chain rule and keeping in mind that y is a function of x. Then we isolate for dy over dx, and we want to get rid of y. So a way to do that is to first draw a triangle and recognize that sine is equal to opposite over hypotenuse, and that ratio is equal to x. And that means the opposite side of y has to equal x, and the hypotenuse has to equal 1. And using Pythagorean theorem, we solve for the third side. Since cosine of y is equal to adjacent over hypotenuse, or square root of 1 minus x squared over 1, we can substitute that in and get the derivative of arcsine of x. Next video, I'll be covering applications of derivatives. Thank you guys for watching.